Welcome back to session 19 of GED Science Mastery. Good to see you. Today we take a word you already know, work, and give it the exact science meaning. Then we connect it to simple machines, power, and efficiency. The GED likes these questions because they mix plain reasoning with small, friendly formulas. If you remember force times distance and work divided by time, you will be in very good shape. Let's get to work. Here is the big idea in plain words. In everyday speech, you might say you worked hard if you pushed on a heavy wall. But in science, work only happens when a force actually moves an object. If the wall does not move, the physics work done on the wall is zero. The force can be huge, but without distance moved, the work is zero. So train your eye to ask two questions. Was there a force, and did the object move in the direction of that force? The work formula is beautifully simple. Work equals force times distance. Force is measured in newtons, distance is measured in meters, and work is measured in joules. For example, if you lift a 200 Newton box 1 meter upward, the work is 200 times 1, or 200 joules. If you lift a 50 Newton object 3 meters, the work is 50 times 3, or 150 joules. Always write the formula first, then plug in the numbers. Now let's talk about machines. A simple machine does not magically erase work. Instead, it changes how the work is done. A ramp lets you push with a smaller force, but you push over a longer distance. A lever can let a smaller effort lift a heavier load, but the effort side usually moves farther. This is the trade-off: smaller force, longer distance. On the GED, that idea is worth gold because it explains why machines feel easier without breaking the energy rules. The GED may name common simple machines: a lever, a pulley, an inclined plane or ramp, a wheel and axle, a wedge, and a screw. The shared idea is mechanical advantage, which means the machine multiplies your force or changes its direction. A longer ramp has more mechanical advantage because it needs less force, but you travel farther. A longer lever arm can lift a load with less effort. Again, the machine helps you, but it does not create energy from nothing. Let's read the evidence. A worker needs to raise a 200 Newton box onto a truck bed 1 meter high. Straight up, she uses 200 newtons for 1 meter, so the work is 200 joules. Up a 2 meter ramp, she uses only 100 newtons, but over 2 meters, so the work is also 200 joules. The bars are the same height because the total work is the same. The ramp helps by reducing the force, not by reducing the total work. Now let's solve the GED style question. How does the ramp help, and why is the work the same? Read. Straight up needs 200 newtons over 1 meter. The ramp needs 100 newtons over 2 meters. Choose. The ramp cuts the force in half, which feels easier, but doubles the distance. Work is force times distance, so both methods give 200 joules. Check. The ramp makes the job easier, but it does not make the total work disappear. Power is different from work. Work tells you how much energy was transferred. Power tells you how fast that work was done. The formula is power equals work divided by time. If two people each do 600 joules of work, but one person finishes in 3 seconds and the other in 6 seconds, the 3-second person has more power. 600 divided by 3 is 200 watts. 600 divided by 6 is 100 watts. Same work, different speed. Last big idea. Efficiency compares useful output to input. A real machine is never 100% efficient because friction wastes some energy as heat. That leads to the traps. 1. Thinking machines reduce total work. No, they trade force for distance. 2. Thinking pushing hard always means work. No, the object must move. 3. Mixing up work and power. Work is force times distance. Power is work divided by time. 4. Thinking efficiency can be perfect. In the real world, friction always takes a share. Excellent work today. You can now calculate work, explain the force-distance trade-off in simple machines, compare power, and explain why efficiency is always less than 100% in real machines. Your practice for this session is the 10 questions attached to this lesson. Answer them from memory, and before each calculation, write the formula first. W equals F times D, or P equals W divided by T. To read the full lesson notes and practice more GED Science questions, visit the course page at www.bridgetoexam.com. I will see you in session 20, where we explore waves, sound, light, electricity, and magnetism. Keep going. You are doing great.